The benefits of productization for the construction industry is absolutely huge, because you're basically bringing manufacturers and fabricators at a very early stage of the project, and they are really involved in the technical solution definition with the architects, with designers, and engineers. So this actually secures a lot the rest of the project phases. And by reducing the risk of errors, design clashes, you're increasing their ability to be more innovative, to be also more sustainable, to design better products, and also to modularize those products so that they can be more agile in a sense. This is exactly what we've done with the tower. Is that basically we productize actually all the items of this tower, thinking of how they would be produced, assembled on site, but also disassembled, because at the end the virtual twin of this tower is actually made of modules. If they can be assembled, it can also be disassembled, stored somewhere else, and why not rebuild somewhere else. The modular approach is pretty revolutionary in the construction industry, because what you do is that you bring fabricators and subcontractors much earlier in the design process, and they stop being downstream, dealing with design issues and clashes. They're able to take part in the design process, and they're actually taking part in the technical solution definition. Which actually push them to be more agile in the way they design their own product. That's the first thing. They need to modularize it. They need to also to start thinking of cycle and prefabrication, because at the end, we also want to simplify the construction process and the logistics. So they need to think their product as a manufacturable item that will be assembled in the factory, that will be also a multi-trade component, so that it pushes them also to work with other subcontractors, and to basically think in terms also of logistic and of assembly on site. That's the first thing. Second thing is also that it pushes the subcontractors to think more in an adaptive way. They stop designing products that is a one of a kind. They need to design one solution product that is going to answer multiple problems. So it's also about integrating a generative aspect to their product. At the end, they need to configure the right product for the right case. Productization is a strategy for delivering customized and efficient construction solution. This approach uses virtual twin to enable the application of generative, configurable design strategies. So at the end, the virtual twin is not a still representation of the tower at a certain moment. It's actually a configurable medium that is fed by libraries of different modules. So we had modules for the slabs, we had modules for the stairs, for the curtain walls, and so on and so forth. And we just had basically to attach those libraries to the virtual twin. So this way we were able to create many design variants. What would happen if the structure was in steel, in concrete, in timber. And this way we would also be able to monitor the different life cycle KPIs, to monitor the logistic scenarios. And so that's the power behind the productization, is that the components of your building stop being just, I would say, a simple representation of it. It's actually the exact representation of how it's manufacturable, fabricable, assemble on site, and also recyclable. It's the whole life cycle process that is actually brought in the productization at the very early stage of the project. So what's important to understand is that modularization doesn't mean standardization. A module is actually a smart, adaptive component that is able to adapt itself to different cases, to slightly change, because it's a configurable component. So we're not in a logic of mass production. We're in a logic of smart customization based on generative configurability, and that's exactly what we did for all the parts of our tower. Whether it's for the beams, for the pillars, the slabs, even the elevators, everything was basically modularized to be able to be slightly adapted to the project without disrupting the supply chain or its manufacturability or its logistics. So the first thing that we had to do with the architect was to define the overall shape of the building. So this shape was originally inspired by the Eiffel Tower, but like we continued designing it further. Once we had this overall shape, we designed a system that would basically locate and assemble the different modules, slabs, stairs, functional spaces. And the system had to basically embed different design rules, different behaviors, and also the constraints of those modules. We built this system with using generative tools that help us to embed all those behaviors to be sure to control the different constraints from a very early stage of the project. So the thing that we did was to bring everyone in the 3D experience platform. On one hand, you have designers, architects, engineers who are basically building the 3D specification of the whole tower, which we can call the parametric skeleton. And they're defining all the requirements and the specification of the functional spaces, the path, the different systems that are attached to this building. And on the other side, you have the subcontractors who need to digest this data in order to create the virtual representation of their product and modularize it. So in the middle of this, you have the general contractor, who's the prime integrator of this knowledge, who needs to make sure that all this information is passed seamlessly from one side to the other. And by bringing all those people in the 3D experience platform around one single virtual twin is actually the key for digital continuity, for also a success in the project, because you go beyond the only 3D modeling aspect. You're able to simulate structural analysis, fluid analysis, logistic, and so on and so forth. So it's like a seamless loop that goes through the different dimensions of the building. The general contractor needs to make sure that the virtual twin that is modeled by the architects can be broken down into the different product lines, so that the different subcontractors know exactly what they need to study and what they need to manufacture, and eventually to budget. You're going to have one product line for the timber, one product line for the steel, one product line for all the electrical equipments, and all of this can be monitored throughout the project. So the benefit of virtual twin is actually huge, because it's an incredible collaborative medium that allows you to have one reference that answers multiple questions. A virtual twin is basically a medium that is able to generate a lightweight model for the renderings. It's able to generate a physical model with all the material properties for the life cycle analysis. It's also able to generate a much more detailed version of the model for the bill of material generation. So the virtual twin is actually the most agile, most flexible medium that is actually built by many different people that is able to give many different answers at any time. So that way you're really able to link, I would say, early stage modeling of the project with its detailed phase, with its simulation phase, whether you're simulating structural analysis or CFD analysis, and then go down to how it's going to be produced, linking that with the supply chain, how it's going to be assembled off-site, how it's going to be brought to the site, assembled on site, and so on and so forth. So the virtual twin is actually merging all those dimensions in the 3D experience platform.